Hello everyone, I hope nobody's disappointed with their exam results and going to have a good time tonight celebrating. So, what I'm going to do is try and introduce you to the work we have next week in order that you can apply the principles or the concepts that you learn in the lecture to the practicals a little bit more quickly, because you don't have a lot of time between the lecture and the practical. So what you need to do is go to the VLE, go to the 17C site, go to Term 2, Data Analysis in R, follow the orange blob to the website, and then you'll see that the topics this week are describing normal distributions and confidence intervals. And if you follow the link to that practical, you'll see the lectures and slides for this week, the lecture notes and slides. So the PDF format is ideal for referencing in the practicals or for looking at online. If you're somebody that wants to download the PowerPoint so you can make notes on them in the actual lecture itself, then that's also available here. So the learning objectives here this week are that you should be able to explain the properties of the normal distribution and how we use them in statistics, and be able to calculate probabilities, quantiles and confidence intervals in R. So what I'm going to do is just try and outline to you what a distribution is in general, because they're so important for understanding these ideas. So I'm just looking here at R. Let me go back a picture. So you don't need to worry about the code here at all. It's not something you're being asked to do. It's just because I wanted to draw some pictures for explaining this, and the easiest way for me to do that is in R. So what is a distribution? So a distribution just means the actual values that something can take and the probability with which they occur. So if we took about 1,000 people and we measured their height, we'd expect the frequency distribution of those heights to follow a pattern a little bit like this, or quite a lot like this. Okay, so this is called a frequency distribution. Now if you take very many more people, let's say 1 million, you end up getting something which is a little bit starting to look a bit smoother. Still a frequency histogram. Now if we actually take almost an infinite number of people, so the entire population, so that we smooth this curve out a bit, and we also move forward, scale the area under the curve to be 1, then that's what we mean by a distribution. So this now, because this is the area under this curve is 1, this now tells us probabilities of getting particular heights. So if I want to know the probability of somebody being 2 meters or smaller, then that's going to be given by this grey area here, the area under the curve up to 2 meters. So in R, there's 2 key functions that we need all the time in calculating probabilities and confidence intervals, and those are Q norm and P norm. There we go, P norm and Q norm. So P norm maps the value to a probability, and Q norm does exactly the opposite, so they're the inverse of each other. So looking at our picture again here, if I was to give a value, a height value to P norm, the P norm function, it would give me out a probability. So I give it 2, and it's going to give me the area of the curve here. Whereas Q norm does exactly the opposite. With Q norm, you give it the probability, and it gives you the height. Okay. The reason it's called Q norm is because the generic term for these things on this axis, which are heights in this case, but could be anything, is quantiles. So P norm, you get the probabilities from the quantiles, and Q norm, you get the quantiles from the probability. Now the other thing you're going to need to understand for this week's practical is the sampling distribution of the mean. So what's that? So normally in statistics, what we're interested in is not what's the distribution of a value, but what's the distribution of the samples. In other words, not how likely it is to get an individual person of an individual height, like 2 meters, but what's the probability of getting a sample of people with a height of 2 metres? And it's because we're interested in this, what we call the sampling distribution of the mean, how likely a sample is, how likely a mean is, rather than an individual value, that we have to understand the sampling distribution of the mean. So the sampling distribution of the mean is what you get if you take an infinite number of samples, all of the same size, from a particular population. And if you were then to calculate the means and then plot those, you'd get the distribution of the means. And the key thing about the distribution of the means is it has a smaller standard deviation. So instead of it having a standard deviation of SD, it has a standard deviation which we call the standard error. And the standard error is smaller than the standard deviation. And it's smaller by dividing it by the square root of n. Here we go. So I've got a picture here. If this is the original population of, in this case it's IQ, and we take lots and lots of samples of size 10, then plot the means, the distribution of those means is going to have a standard deviation called the standard error, which is the standard deviation divided by the square root of n. And it's for this reason that when we're calculating confidence intervals on means, where we're asking how confident we are about a mean, a sampling mean, that we use standard errors in those calculations and not standard deviations. And that's all I'm going to say for this week, and I'll see you next week. Have a nice weekend.